particle A moves with a constant speed 2 meter per second on a circular path radius 4 meter. So it's a circle on which a particle is moving with speed 2 meter per second, and the radius of this circle is given as 4 meter. There is another particle B that moves along a straight line through the center of the circular path. So there is another particle B which is moving along this line, suppose, and this line is passing through the center of the circle, and such that it's always maintaining a constant distance 4 meter from the particle A. So the position of B is such that the distance between A and B is always 4 meter. And then we have to tell about the maximum speed of B, maximum acceleration of B, etc. Okay, so this is the question. So as the question suggests, the B, the position of B is such that it is making 4 meter from A. So this is also 4, the radius of circle. This is also 4. And if you drop a perpendicular from A onto this line, suppose this line is x-axis along which B is moving. So this perpendicular, the foot of perpendicular will lie at such a position that it will divide these two triangles in exactly equal triangles. They are congruent triangles. This you can verify. This angle is 90, 90 here. These two sides are same. This side is common, so it's a congruent triangle. Congruent triangles. So whatever distance is from center to this point, to the point of foot of perpendicular, the same distance will be from this foot to B. So if you find that distance, it will be 4 cos theta. So the position of B will be 8 cos theta comma 0, assuming this line to be x-axis and center at origin. So we have found the position of B. So rest of things will be done mathematically. So let the x coordinate of B is 8 cos theta, then differentiate this. D theta by dt is the angular speed of particle A, and that is V over R from the property of circular motion. Omega, angular speed omega is V over R. So from there, just put the value of V and R. So this is coming out equal to minus 4 sine theta. Now to find acceleration, differentiate this again. Put the value of d theta by dt again. Okay, so we have found the expressions for velocity and acceleration. So from these expressions, we can easily find the maximum values of V and A. So V maximum is 4. This you can easily see. The maximum value of this expression is 4 when sine theta is minus 1. And the maximum value of A will be 2 when cos theta is minus 1. And the range of x will be from minus 8 to 8, easily seen from this expression. So because cos theta varies from minus 1 to 1. So the particle will move from 8 comma 0 to minus 8 comma 0 as this particle A moves from here to here. And when particle A comes back, B will move from minus 8 to 8 again. So this is the total distance covered by B from minus 8 to 8 to minus 8, and then from minus 8 to 8. So this is the total distance covered by B as this A moves along a full cycle. So the distance moved by A will be, the distance moved by B will be 16 plus 16, 8 plus 8, 16 in this side and 16 in this side. So option C is correct. During one revolution of A, distance traveled by B is 32. Option A is correct. Maximum speed of B is 4 that we have seen. Option B is correct. Maximum acceleration of B is 2 meter per second square. Now we have to see modulus of velocity of particle A relative to other. So relative velocity. So we have to find relative velocity. See the velocity of A here in this diagram. It is 2 meter per second, making an angle theta. This you can verify easily that this angle is theta. This is 90. So here it will be 90 minus theta. This angle is 90 because radius and tangent they are perpendicular. This total angle is 180. So this angle is theta. So the component of this velocity 2 will be 2 cos theta in y direction while 2 sin theta in minus I direction. So write that. So V can be written as 2 sin theta I plus 2 cos theta j. Similarly, VB is minus 4 sin theta along x direction. So it can be written as minus 4 sin theta I cap. So to find relative velocity, subtract these two and find their mod. And just putting the values and solving, that's coming out 2. So it's a constant. So therefore option D is correct. So we find all these options to be correct, A, B, C, and D. Okay.